Hi, Dr. Elaine. I am submitting a reassessment of my Newton's second law standard. Um, and the question I'm attempting is that a woman's pulling her suitcase through an airport terminal and the wheels fall off. So she ties a rope to it and drags it along the floor. The rope makes a 40-degree angle with the horizontal, and the suitcase has a mass of 36 kilograms. She pulls on the rope with a force of 65 newtons. So I'm finding the magnitude of the normal force acting on the suitcase due to the floor, and then if the coefficient of kinetic friction between the suitcase and the marble floor is mu k equals 0.13, find the frictional force acting on the suitcase, and then the acceleration of the suitcase while she pulls with a 65 Newton force and at a 40-degree angle. So, I kind of have a little diagram of what I was explaining. So she's pulling on, this is her suitcase with 36 kilogram mass, and she's pulling with a rope at a 40-degree angle with a force of magnitude of 65 newtons. And here's my free body diagram of that. So we have the normal force going up, the weight of the suitcase, mg, down, and then her force, 40-degree angle force, and then the friction force pulling back. So first I just want to think about her force being resolved into x and y components. So F cosine 40 and F sine 40 would be the x and y components of this force. So I kind of solved them out just so I can substitute them in later. So the force in the x component of that force is 49.8 newtons, and the y component would be 41.8 newtons. So now I'm going to solve for the magnitude of the normal force. So my F net in the y direction would be n plus F sine 40 minus mg. Get that from here. So then that could be n is equal to mg minus F sine 40, so we can solve for the normal force. So then I want to substitute in my values. mg would be 36 kilograms times 9.8 newtons per kilograms. And I want to subtract F sine 40 from that, which I already solved up here. So I'll substitute in 41.8 newtons right here. Subtract that from 36 times 9.8, which is 352.8 newtons minus 41.8 newtons. So I get 311 newtons for the magnitude of the normal force. So next I want to find the friction force. So that's going to be equal to mu k times n. And mu k is given as 0.13. And then the normal force we just found is 311 newtons. So 0.13 times 311 newtons would be 40 newtons, 40.43 newtons. Okay, so next I want to find acceleration. And I need to use the friction force that I just found, and then I'm going to be using my F cosine 40, which I solved earlier. So let me get that value from up here. 49.8 newtons would be F cosine 40, and I'll substitute that in. And then I'm going to subtract out 40.43 newtons, the normal force. So I get 9.36 newtons in the x direction. So the acceleration in the x direction would be 9.36 newtons, or the F net x, divided by the mass of the suitcase. So that would be 9.36 newtons, which I solved for in the last equation right here. 9.36 newtons divided by 36 kilograms, mass of the suitcase, which gives me 0.260 meters per second squared, which would be the acceleration. Okay, thank you.